Hey guys, I wanted to just do a quick recording of the Zoom lesson today because I used my document camera and the example from Gladwell. So I just wanted to kind of go through that in case people needed or wanted to see it again or they were absent. So I'm going to share my document camera here and I'll move my page around a little bit here. So this is a section from the chapter in Gladwell where he talks about and makes the argumentative claim that Asians have a built-in advantage in math. And so I'm going to write the claim up here at the top. Asians have a built-in advantage, A-D-V-A-N-T-A-G-E, in math. Okay, so that's his central claim. I apologize for my sloppy handwriting. Asians have a built-in advantage in math. Okay. This is what the big idea that he's ultimately trying to argue. All right, and so what we've got here is we've got the topic sentence is how he starts it out, right? Like this isn't his whole argument. This is just one of the points that fits into this big idea. Okay, and so he's going to use inductive reasoning here. He's got his topic sentence, which you guys know what that is. It turns out that there's a big difference in how number naming systems in Western and Asian languages are constructed. Okay, so this is the special case. So in inductive reasoning, you've already done the experiment, and so now you can go back and derive your general principle from that special case that you've already tested or observed. And so in this example, Gladwell has looked at the number naming systems of Western and Asian languages and determined the general principle that Asians have a built-in advantage in math, as well as whatever simple points he argues here. Okay, and so the next few sentences are context for his evidence. Until I read this book, I didn't know the difference between the number naming systems in Western and Asian languages, and chances are, unless you speak them both, you don't either, okay? And so Gladwell needs to take a little time and explain in context, give us details on the differences, right? So that we can follow along with his comparison and understand his argument. And so he is using facts here, because this is verifiable information that he can research. And so these are this is going to be a fact-based point. Now, there's other parts in Gladwell's book where he makes value-based points, but this particular one happens to be a fact-based point. Okay? And so the question that he's answering here, because that's what you're doing when you're arguing, is answering questions, he's answering what? What details about the differences between number naming systems in Western and Asian languages are important and valid to this discussion? Okay, I don't know what that is, and now I do because he's told me the what's important. Okay, and so when you get down here, this last sentence here in this first little section, this is where he starts to actually argue. He says the number system in English is highly irregular. Okay. Not so in China, Japan, and Korea. They have a logical counting system. Okay, so we're supposed to compare these two things. 11 is 10-1, 12 is 10-2, 24 is 2 10s 4, and so on. Okay, and so if you learned math in elementary school using 10 frames and stuff like that, then you've learned, partly anyway, how to count and how to add simple numbers together with this Asian number naming system in mind. Okay, when I was a kid, we didn't use 10 frames in school. We had to memorize addition and subtraction facts just by brute force through memory. Okay, and I think a lot of kids struggled with that because of the irregularities in English. That's just my personal experience on this. But Gladwell is looking at the research here, so let's stick with Gladwell. But when he starts arguing here, the question that he's answering is why. Why does the number naming system give Asians a built-in advantage? Well, they have an advantage because the English language system for naming numbers is highly irregular, whereas the Asian counterpart system is logical. Okay? So he's giving us a why. He's not letting his evidence speak for itself. He's connecting his points and building a line of reasoning, which is super important. Because if he basically just says, here's the evidence, and then he skips down here to the bottom where he gets to his important point that American children are already behind by age 5, I could probably draw reasoning out of that. But if I'm the one connecting his facts to the meaning and his claims, then that's not his argument anymore, because I'm the one who did all the thinking and the logic and the reasoning for it. That's my argument now, okay? And so Gladwell has to include all the steps in his proof, okay? Even if he knows what the answer is based on the example, when he's laying it out for an audience, he still has to put in all those steps, okay? That allows us in the audience to follow along with his argument, not develop our own based on his evidence. Okay, there's a distinction, important thing for that. And so in this bottom part, where he kind of gets to his point for the overall paragraph here, he says that difference means Asian children learn to count much faster than American children. 4-year-old Chinese children can count on average to 40, and American children at that age can only count to 15, and most don't reach 40 until they're 5. Okay? And so he concludes that by age 5, American children are already a year behind than their Asian counterparts in fundamental math skills like counting. Okay? So this question that he's answering here is how? Okay? Well, Asians have a built-in advantage in math. How? How do we know that? Well, by age 5, Asian children are already a year ahead of children from other cultures. Okay? Why? Well, it's based in the language. English is highly irregular, for instance, in how they name their numbers and their number naming systems, whereas Chinese and Korean and Japanese have a more logical counting system. Okay? So he's taken a special case, he's taken facts from that special case, and through that, Malcolm Gladwell has made this observation down here at the bottom. American children are behind. And he's using that to support his big idea that he's developing from this data that Asians have a built-in advantage in math. And so it's not like, he sat down and said, you know what, I think that Asians have a built-in advantage in math. Let me just test it and see if it works. He sat down and said, look, I looked at this special case, these facts, and I determined that Asians have an advantage, and that advantage is based on the language. Okay? And so, this is inductive reasoning. He started with a special case, and he's worked backwards to derive this claim. Okay? And so what that looks like for you, you have your big idea, and you might have examples. And within each of your examples, you can have multiple points, right? So when you write an essay, an argumentative essay, this is kind of how it flows, right? You introduce your big idea, and then you take time to introduce examples and the points that go with each example, okay? And then by the end of the reading, your audience should be back around to that big idea, and they should see what's going on, and they should see it work, okay? But when you're planning an argument, I don't want you to take the gut reaction, start at the big idea, because then you have to come up with the lottery, right? You have to find the special cases that fit examples when you've put stringent conditions on where you can go, okay? Find the special case first. If you get a topic, which is going to be in the prompt, and you have a gut reaction and start with a big idea, now you're using your time trying to think of those pegs, square and round, to fit into the hole, right? Don't start with the big idea. Take the topic and ask, what special cases does this make me think about? Okay? And then take those special cases that pop into your mind, those examples, and ask, what points can I make with these examples? Then add your points together into a line of reasoning. Okay, you've got points. Make a line. Okay, once you've made that line, whatever that leads you to becomes your big idea. Okay? So when you present the paper or you present the argument, it's going to look like you knew what you were doing the whole time. Okay? Because you're going to give them a big idea, and it's going to lead naturally into these examples, which lead naturally into the points along the line that create the big idea. Okay? But don't think that going into your paper, you're going to be able to come up with a gut reaction and then find the perfect evidence. Okay? Come up with the evidence first, and then determine the points that you can argue, connect those points together, and argue the point, the big idea. Okay? So, if you do this, you won't be wrong, because you've already done all the thinking along the way before you've even claimed something. All right? So, as we practice this week, make sure that you are thinking ahead, coming up with those special cases first, and then connecting your points. See you in class.